and this is lecture number 14. Refraction. What was the last thing that we discussed? Specifically, can you tell me which problem it is?
Find length of convex lens in a figure.
What kind of figure do we have?
That is only find the gain position.
Acha. So there was a object. Did I do that question on board?
No.
I did not. So let me discuss it then. How many of you were able to do it? I think this was very similar to a question that we have already done in mirrors, no? Yes? So, question number, can you remember?
That was 7.
Question number 7 I gave you, but I think in sheet number 6 is question number 1 or 2. I don't know. Can you check? So let me write it in that manner. Sheet 6, question number 2. And the diagram was something like this. You have a convex. You have a convex lens. There is an object moving with some velocity 5 millimeters per second. What is the angle made? 37 degrees. What is the object distance given to me? 30. This is my object, this is my P. Yes? Now they are asking to find, how do you used to imagine this? We can imagine it like maybe the object was moving, it always is moving with the velocity, this velocity. And at this point we take a snapshot. When we take the snapshot, then where is my image found? That is what we are trying to find. Where will the image be found? How to find that? Any relation between u and v? Bolo? 1 by v minus 1 by u is equal to 1 by f. No? But what is f given to you? 20. Should I take it as positive or negative? But how many in favor of negative? How many in favor of positive? It's a convex lens, no? For convex lens, when I talk about f, I am basically talking about f2. And f2 is positive every time for convex lens. So it's going to be plus 20. What is u? Minus 30. Then what will be v? 1 by 20 minus 1 by 30. I think you will get something like 60. Yeah, 1 by 60 are right here. And then what will be? It's 20 plus 60. Please check my calculations. Then what will be? Acha, they are asking to find the velocity vector. Then how do you use to find the velocity vector? By using those relations. If you are moving perpendicular to principal axis or parallel to principal axis, you have two equations. There is a m square times the component and m times the component for length. Then I need to find m. Then what is the m formula? That's v by u. 60 divided by what is u? So this will be minus 2. I should write my coordinate axis as well. Let me take my coordinate axis as this is I cap, this is j cap. Is it okay? That what will be VIY? Can somebody tell me this? What is VIY? Should it be m times VOY or m square times VOY? M square. It should be m square times VO. What about VIX? That's m times VOX. Do you understand these terms which I have written? These are the image component along y direction. This is the object component along y direction. What is m square? That's 4. What is VOY? Can somebody tell me the component along y direction?
3. Or by 4.
This is basically 5 sine 37, no? Yes? 5 sine 37? 5 sine 37. What will be for this? This will be minus 2 into 5 cos 37 this time? Because it's along x. Can you see? This is a very simple vector. So 5 cos 37. ये बताओ values बताओ.
3/5.
This is going to be 4/5. I think you will get 16. Is that correct? Please check. What will you get here? Exactly as before. Then what is the VI vector? What is the VI vector? It's VIX I cap plus VIY j cap. I have done nothing new. I have already discussed exactly same question previously, right? So, क्या बोल रहा है?
Sin 37 is 3/5, right?
Sin 37 is 3/5. I don't know. You tell me. Is it 3/5?
Yes.
Sine is a increasing function for 0 to 90 degrees. So sin 37 has to be less than sin 53.
For that triangle, it's 4/5.
For that triangle. If I take this to be my, this is my vector. This is 37. क्या है बताओ? 3/5?
Yeah.
Then what will be the y component? Can you check if this equation is correct? M square or m times? M square है correct है? देखो जरा. I may have done a mistake here. So if it is 3/5.
If it's parallel, it's m square in your case.
For parallel it's m square.
Yes, sir.
So that means for x axis it's m square. And now I think you will get something like -6 here and you will get 16 here. So 69 minus 60 is what I am getting. Anybody got the same answer? Good. Is this answer complete?
No.
What do I have to write? Anything else?
Take the 90.
I should mention the units. Without that, it's completely useless. Millimeter per second. Anyways, I think this was asked in the question. The image velocity vector and image position. Yes. Why are you so depressed? Did you do the question? Then attempt. Why 12?
Sir, you need to keep -2 in the place of 4.
Acha, yes. Either -2 is 0 here. Either 4. Is it correct now?
Yes.
Hopefully it is correct. Great. After this, did we talk about this convex and a concave mirror वाला question? A convex उसके सामने एक concave. I might have done it.
Yes, sir.
Yes, sir.
Not a mirror, rather a lens. Now let's try to do this question. Again, a question that we have already done in the class, but making the ray diagram is going to be interesting. Question number 3, maybe from the sheet. And the diagram is something like concave. So this is given to be 30 centimeter. Again, a question that I have already done in the class. Hopefully this is question number 3. Yes. Hello. Anyone has any doubts in the previous question? Coming in.
What is it? D?
What is option D?
Minus 20 centimeters.
Plus 2 by 3.
Ah.
That's correct. Can I start with the question now? Exactly as a question that we have already done. Yes, correct. The interesting part of it is, can you make the ray diagram? That's interesting. But anyways, the question is fairly simple. Exactly like the way in which we have done it previously. How do you do it? You have to find magnification. Huh? For that, you want the image distance as well. How do you find the image distance? Fairly simple. What is the focal length given to be? Plus 60 or minus 60? Minus 60. It's going to be f2, and for concave it's negative. So f is minus 60. What is u? Minus 30. Then 1 by b is equal to minus 1 by 60, then plus 1 by 30 actually. Please check my calculations. And that you will get as no? If we do it 1 by plus 1 by u, so minus 1 by 60, minus 1 by 30. Is this correct now?
Yes, yes.
I keep on losing some. I think it's minus 20. Is it correct? That's v minus 20 centimeter. And then what will you find m as? V by u. And that is going to be minus 20 divided by u. What is u?
Minus 30.
So this is going to be plus 2 by 3. Just by looking at the value of m, can you conclude some things?
Virtual characteristic.
But the nature of image is what? Enlarged.
Diminished.
This is less than 1 clearly. So it's going to be diminished. What about real or virtual?
Virtual and erect.
Virtual, because it's a positive value. M greater than 0, that means virtual. And if you have a virtual, there is erect. Virtual meaning what? Where should my image be formed? Right or left?
Left.
Left. Either kind. Yes. So the image will be something like this, maybe a little. It's not even inverted; it's erect. So where will this will be C prime, B prime, and A prime. Try to make it by ray diagrams. Do you understand? Good. This was question number 3. Now, a very interesting question, question number 4. Is that the question of plotting the graph?
Yes.
Great. Go. Plot. So, Akito, I have not given my rant about the pre-Vikalpa exam. That was the wonderful results that you gave yesterday. I will talk about that as well. But let's see who can do this question. I will give you 3 minutes. After that, I will start. 12:19. If you go for this 1 by V versus 1 by U graph, that's much more simpler. I think you can do it.
This is the.
That's 1 by V versus 1 by U. Incorrect. Even the nature of the graph is not. Incorrect. Incorrect. Only 1 minute left. This is not that hard. No, that is incorrect as well. Anyone? I should start then. Nobody even gave me 1 by V versus 1 by U graph. That was a simpler one. I am talking for lenses, for convex lens. To be specific, for convex lens. For convex lens, we are trying to make 1 by V versus 1 by U. Let me write the graph here. If you remember, we will follow the same procedure as done in mirrors. And how do we start with? Start with the equation that relates the two. 1 by V minus 1 by U equal to 1 by F. That means 1 by V is equal to 1 by U plus 1 by F. If you recognize that 1 by v can be taken as y-axis and 1 by u as x-axis, then what can you say? Y is 1 by v, x is 1 by u. Then what kind of equation looks like?
Y equal to mx plus y.
mx plus c. So what is the slope? That's plus 1. What about the c? That's 1 by f. Will this c be negative or positive?
Positive.
Why positive?
Convex lens
It's a convex lens. For a convex lens, f2 is positive. So you will have a straight line with a positive slope. That means what? If you remember, for mirrors we had a negative slope, so the graph was going like this. Now you have a positive slope, the graph will go like this. But how will the graph cut? Will it go like this, or this? How? So I have to take into consideration where it is cutting the graph, where it is cutting the axis. Where does it cut the y-axis? At a positive value, I think. Yes? So it cuts at a positive value. What are the coordinates of this? 0, 1 by f. Does it make sense? What about the x-axis? Where will it cut on the x-axis? For that, I just have to put 1 by v equal to 0. Are you understanding?
Yes.
I want to find the x coordinate at which it will cut the graph.
Minus
For that,
1 by
I
f.
have to put.
Minus 1 by f.
So 1 by v equal to 0, guess what? 1 by u equal to minus 1 by f. So will it cut out the positive x-axis or the negative x-axis?
Negative.
Negative. So I should have one of the coordinate here, so it will cut out. Then what will the graph look like? It's a straight line with a positive slope, which is cutting the 2 points. Do you understand? This was a simpler graph. 1 by v versus 1 by u. Let's try to look at the more interesting graph, that is the v versus u. V versus u. So let me make some asymptotes. One of the asymptotes is this. The other is this. Let me make some more here. If you remember, I did the same thing when I was doing for mirrors. This is F, this is 2F, this is minus F, this is minus 2F. This is minus F, this is minus 2F. Please understand all the lines very, very carefully. The y-axis is V, the x-axis is U. Where will the horizontal lines cut? They will cut at the point where V value is given, na? Where will the vertical lines will cut? For some U values. If I place my object at 2F, where is my image formed? At 2F. If I take my object at 2F, then U is what? Negative or positive? Negative. Actually, by the way, U is always negative, na? Yes? That's why I did not make any kind of asymptotes in this quadrant, the first and fourth. You will find nothing in the first and fourth quadrant for now. You will only find anything here in the second and third quadrant. So, बताओ, U की value minus 2F या plus 2F? Minus 2F, na? What about V की value? Will it be plus 2F or minus 2F? Plus 2F, na? Because if I have a lens here and I place my object here, then where is my image form? Here, no?
Yes.
So it's plus. This is minus. So if I place my object at minus 2F, I will find my image at plus 2F. So U की वैल्यू क्या है? माइनस 2F यहाँ पर है. V की वैल्यू प्लस 2F यहाँ पर है. यहाँ पर कहीं. Are you okay with that?
Yes.
If I place my object at focus, where will the image be formed? Object at focus goes to infinity. Positive or negative?
Positive.
Positive. So ये focus ये minus f value रहेगी ना U के लिए तो. So U negative, what will be V? I think it will go something like that. Does it make sense? If I place my object at negative infinity, where will my image be formed?
Focus.
At focus.
Plus
At
F.
plus F. So ऐसा कुछ आना चाहिए क्या? And if I connect the whole graph, this is not so good, but I think if you connect the graph, you will get something like that. This, what regions did I consider between focus and infinity? What region is remaining? Focus and pole. What is the nature of the image between focus and pole? Virtual or real?
Virtual.
It's virtual. For lenses, virtual में V and U का same side या opposite side?
Same.
Same side. So if I find my U to be negative, then my V will also be negative. So I will not have the graph now up. I will have it down. Does it make sense? अब बताओ, if your object is placed at pole, where will your image be formed?
Virtual. Same side.
At pole, na? If you place your object at pole, you will find the image at pole. So ये point है. And then, if your object is placed towards the focus, where is the image formed this time? Be very careful with your answer. Virupaka, listen. If you place your object at focus, where will your image be formed? Between P and F.
Beyond center of
Between.
बताओ ऑप्शन
Moving towards the center.
क्या है आंसर क्या होना चाहिए?
B.
Minus 2.
Why minus infinity?
Because
it's focus.
So if you place your object at focus, you are surely going to get infinity image distance, but negative this time. Why negative? Because it's formed at the same side between P and F. So this time the graph is something like this. If you remember, this is exactly the mirror image of the graph that we have done for mirrors actually. Mirror image of mirrors. So there we found something like this. कि ऐसा कुछ जा रहा है and then something like this. Huh? Do you remember? Exactly the different part. Good. This is for convex lens. You can take for concave lens as a homework. Anybody who did not understand any of the regions, please ask. समझा पूरा? If you have any of the regions that you did not understand, then please ask. Otherwise, copy. Remember, I have done all the discussion only for convex lens. Try to listen again. What happened? You left your pen, that's why I depressed. You want to sit with him again? Not even writing the question number. You're very zoned out today. Very good. How much days? How many days were you having holidays? I think 2-3 days का holiday था ना बीच में? He's the only. I think मेरा lectures we can. This is good. Why did you give me any notes? You didn't ask him. No, Papa, you lied. He said he gave you a message. Late night WhatsApp chatting. They are very close. Badao, you done? Can I go forward? Please make these lines. These are actually called. Let's forget what it is called. These are lines, broken lines. Or asymptotes, but you do not understand what is broken. ठीक है. What is the next question given in the sheet? ठीक है, ये इक्वेशन भी कर लेते हैं. I will give this as a homework. This is a very simple one. So take it as a homework. Question number. I don't remember what's the question number. 5. The graph is something like this, or rather the diagram. Take it as a homework. There is one more question. I will even give this as a homework. Now I think you have to find the focal length. You have to find the focal length of this system. Try to take it, try to do it at home. If you don't get it, anyways, I will discuss on the board later on. Okay? Leave a page. We are going towards the end of the discussion of this. Acha, I should have also told you this. Okay. There are only 3 parts remaining. There is one part which is the lenses basically, and we are nearing towards the end of this discussion of lenses. Then we will talk about prism. Okay, we will have a lengthy discussion on that. Then there is a topic called optical instruments, but that optical instruments it's not asked in advanced. It's only asked in mains. So what we will do is we will not talk about optical instruments for now. We will keep it on. We will keep it on hold. Try to do it at the end of everything. Okay? So that when your exam is nearing, the whole topic will be fresh in your mind. Is it okay? In optical instruments, we will discuss about microscopes and telescopes. Very interesting stuff. But later on, not now. So after prism, we will go to a new chapter. Anyone has any problem with that? Great. So take this question as a homework and let's go to some important points. Some important points. And the first point is, what if you have a lens and let's try to cut it? What if I cut it, then what will happen? So, let's say you have a lens like this. Yes. And let's say I cut it from here. Then what will happen? The thing after this should look like this. What is it? Plane of convex. You will get 2 plane of convex lenses. Actually, remember that whenever we talk about lenses, then in general, the most important bit is called the focal length. Once you know the focal length, then we can talk about so many things. Where will you place your objects, or where will you find the image? And then all those things. And even if you know power, it's basically the same thing because power is 1 by f. So if we have an initial setup like this, and let's say the initial lens has a focal length f, and power p, what will happen to the focal length and power here? We'll try to discuss that. So let's say the focal length and power here is f dash and p dash. Let's try to get that. Huh? What will be the value? Then what is the formula for focal length? Do you remember? It's something like this. 1 by f is equal to mu2 by mu1 minus 1 by r1 1 by r2. If I take an equiconvex lens, then what will I get? For equiconvex lens, what is R1? What is R1? Can somebody tell me? I think R1 can be considered as plus R. Then what will be R2? What will be R2? They are equiconvex. That means the magnitude has to be equal.
Minus.
This will be minus R, no? By sign conventions. Minus R. Then, and let's say the surrounding medium is air. Then what will be mu1? That's 1. And mu2 can be considered as mu. Then what will you get? 1 by f equal to mu minus 1. I think you will get something like 1 by r plus 1 by r. That will be 2 by r. Is it okay? Let's try to do this for here. Then what will I get? 1 by f dash will be mu minus 1. What is r1 here? What is r1 here? Plus r, right? What will be r2? Infinity. Very good. So this will be 1 by r minus 1 by infinity. In there you will get something like mu minus 1 by r, 1 by f dash. Then can you make some kind of relation between 1 by f and 1 by f dash? Is there any relation between them? I think there is a factor of 2 somewhere. बताओ क्या डिवाइड मल्टीप्लाई कैसा इक्वेशन बनेगा? I think 2 by f dash is equal to 1 by f. Huh? 2 by f dash equal to 1 by f. Then what can you conclude?
F dash equal
1 by f. So f dash is equal to
2f.
2f. So when you cut a mirror, when you cut a lens, your focal length increases by a factor of 2. What about the power? What will happen to power?
Decreases.
It decreases by a factor of 2 now, because this will be power is equal to p by 2. Does it make sense to you? So when you cut a lens in this particular fashion, very careful, you have to cut a lens in this particular fashion, then your focal length increases by a factor of 2, power decreases by a factor of 2. Is it all okay? Now let's try to cut a lens but in the other way. Let's do it like this. Then what happens? Is it done? If I have something like this, and now let's try to cut it like this, then what will happen? Then you will have one lens like this, one lens like this. You don't need any derivation here. If the focal length is f here and power is p, can you just by looking at it and tell me what will be the focal length here and power? It will be the same. Very good. It will be the same. Because the surfaces have not changed. It's just you cut it, doesn't mean your focal length will change it. Then let me ask you this. Focal length basically decides where will your image be formed, what will be the nature of your image and all those things. It also talks about what will be the nature of the lens, converging or diverging. If your focal length and power are exactly same as before, then you can say that the nature of lens, the nature of image form, all of them are same. Then what is the difference between the two?
Magnification.
How magnification? If I place my object somewhere, Focal length is same, image distance will come out to be same, m equal to b by u, so it's the same. What will change?
The side of the image.
Size, magnification, same.
There is no pole in the.
There is a pole, obviously. Yes, there is a pole. See,
Half,
what I am
only half
talking
of
about
it.
is I am trying to compare this and this. What is so different between them? What can
half
be
is
visible?
visible. Full image not visible.
Uh-huh.
Full image is not visible.
It will be visible. Whole image will be visible.
Principal axis. Principal axis.
Principal axis, they can have the same principal axis. It's not matter. What is different then? No, you can't make such conclusions. The nature will be the same as I have said already. See.
Intensity.
Uh-huh.
Intensity.
Intensity, very good. The thing that will be different will be intensity. Because here, when image was formed, I think rays were coming from all the directions. I take only two rays just to make the diagram. Does not mean they are not coming from the bottom half of the lens. Here I cut the bottom half. So there is no rays from here. It's only rays from here. So half of the rays are not even going there. That means what? What will the image be? It will be a little dim. It will have less brightness. Less brightness means less intensity. Do you understand? This will make little dim images. Here you will have bright images. So let me write that statement. Is it all okay? This was point number 2. When you cut a lens in this fashion. Going on in the same point, if I do cut it, and let's say the lenses are kept like this, and their initial principal axis was somewhere here, and I have my object over here. How will the image be formed? Can somebody tell me? What kind of image? How many images will you get? Let me ask you that. How many images? Two images. Anybody else? So it will be something like this. I will not waste some time. So ये ऐसा आएगा. This is the principal axis of this lens. And with respect to this principal axis, how is the object placed? It's placed inverted. Huh? I am not talking in general, but maybe there may be a case in convex lenses where you will have an inverted magnified image. And maybe the image I1 will be something like this. What about for this lens? Yes, then the image will be something like this. Are they even coinciding? No, the images are very independent of each other. Do you understand? In general, you can't say that it will be magnified or it will not be erect. I'm just taking any case, just to show you. Good. Can you tell me the ray diagram for this? This is very simple actually. But let's say this is the pole. One of the rays passes through. The diagram is very hideous. Something like this maybe. And one of the rays will go like this. Will go like this. Actually, it should be parallel to principal axis. Huh? Hopefully you understand. And then you can make 2 more rays just here as well. Great. This was point number 2. Point number 3. What if you have a setup like this? What if, I think I have already given you a formula for this setup, where you have 2 lenses which are placed very close to each other. ये पता है इसका? How to find the equivalent focal length? 1 by f1 plus 1 by f2, very good. But now let's say if I place some kind of liquid or maybe some kind of material in between them, then what will happen? Then how should I imagine this? I can imagine it like this. Maybe I can consider this is one lens which is connected to another lens. And what is that lens? Something like this.
Yes.
And then there's a third lens. Do you understand? When you place some kind of material in between the lenses, you can consider that material to be forming another lens. Yes? Let's say this is lens L1, L2, L3, and it has a refractive index mu1, mu2, this will be mu3. Now let's try to, you tell me what should be the radius of curvatures. So let's say if this is radius of curvature R1, this is R2, then what is this radius of curvature? What should that be? It should be R2 again. Why? Because it is fitting onto this now perfectly. Do you understand? These two surfaces, this surface and this surface are fitting onto each other. That means they have the same radius of curvature. So ये हो जाएगा R2. If I say this is R3, then what is this?
R3.
R3 again, and in general this is R4. Why am I writing all of this? Because I want to write the F equivalent by the formula. So for that I have to find the individual focal length. Then what was the formula of individual focal length? I just wrote it.
1 by f equal to
1 by f equal to mu2 by mu1 I used to write. But let's consider the outside material medium to be air. Then what will I write? A R
minus 1 by r.
Okay. For f1 this will be 1, 1, 2. Here I write it correctly, please check. This is for lens 1, the focal length. What will be the lens 2 focal length? Batao, can somebody tell me the equation? Please remember, this is basically mu of lens divided by mu of medium outside minus 1 of that. I am taking mu of medium to be air and this is mu of lens which I am writing to be mu1. Okay? How should I write it now?
mu2.
mu2 minus 1. What should I write?
1 by r2 minus 1 plus
1 by r2 minus
1 by r3.
1 by r3. Is this correct? What should be the last one then? 1 by f3, that's f3 minus 1. 1 by r3. This is how you find the individual focal lengths. Then what will be the equivalent setup the focal length? What will be f equivalent?
1 by f plus 1 by f1
That's
plus
1 by f1 plus 1 by f2 plus 1 by f3. Yes, everyone knows this, right? Good. So if you place some kind of medium in between two lenses, then you follow this formula. Is it all okay? Can I go forward or should I wait 1 minute? Midterm. Yeah, that's anything, right? Sure. Anybody from here who would like to sit at the back? No. Rafi, you want to sit at the back? Take care. Is this done?
Yes.
Great. Now let me ask you this. Very interesting stuff. This is point number 4 now. I made this bigger and I am asking you what kind of lens it is.
Convex.
How many in favor of convex?
So without the medium we can.
Aha.
Without the medium we cannot do it.
Good, very good. Without the medium, you can't in general comment. I did not say, because the nature will be totally different, na? It can act even as a converging lens or a diverging lens. Let's say I give you it's a convex lens, and then I do this very interesting thing. Now I do this. What did I do? Silvering kar diya. How will that surface act like? It will act like a mirror now. Then what? Should I call it a lens or should I call it a mirror? It's basically, if you remember, it's basically like a mirror only with some kind of medium in front of the mirror. Some kind of medium in front of mirror. Can you imagine? Basically a mirror with some medium. Achha, how many, when the rays are coming, how many refractions, how many reflections?
2 refractions, 1 reflection.
So, very good. It will be something like this. One ray is go and comes like this, then you will find some kind of image. Yes or no? I am not going to derive how to find. So for this setup, you have to also know the focal length. I am not deriving it, I am just giving you directly. Is it okay? The derivation is fairly simple. You can check it if you want in page number 95 of DC Pandey. But I am going to give you directly the formula. The formula of the focal length is this 1 by f, which is actually, now the interesting part is, should it be equal to 1 by v minus 1 by u or 1 by v plus 1 by u? No, it will be plus, but because this is acting more like a mirror. 1 by u plus 1 by v, this is equal to 2. So I should write it here. Mu2 by mu1 by r2 minus 2 mu2 by mu1 minus 1. This is the formula. Good. This is the formula. And what is mu2? What is mu1? You understand that, right? Mu2 is the lens refractive index. Mu1 is the surrounding refractive index. I just want to talk about one more thing, then we can be off to problems. So, we have talked about how to find focal length by some geometric means or maybe something like that. But how to find it experimentally? It's a very interesting question. Given nothing, given only a screen and a convex lens, how do you determine its focal length? And the procedure is this. This is called the displacement method. Displacement, so write with me. Displacement method for determining, for finding the focal length of the convex lens. Now listen to this very carefully. So, this is a setup. You have a screen here. A screen. You have a convex lens here. And there is an object over here. The whole process is this. So let me define the whole process. Let me read out the whole process. Then we will try to find it. You place your lens at some position with respect to O. With respect to O, what is this distance?
U. Object
That's
distance.
U. Let me call it U1 for now. Okay? And I am going to talk about distances. No sign convention or anything for now. I can say that the object is placed at minus U1 with respect to the lens. I can even say that the object is placed at U1 with respect to O. With respect to O, lens is placed at U1. You will find some kind of image on screen. You will find an image. Now what do? You displace your lens. You keep on moving it back and forth. At some point you will find the image again which is sharp. Okay? At some distance, let's say you have displaced it, you came here. This is your next position and the distance here is x. What will be this distance? U2. U2. And you find the image sharp again. By sharp, what do I mean?
Point.
Same intensity, same everything. You will find the image. Then using just this, you can find the focal length. This is the procedure. And let's try to do it how it happens. So what was the thing? You place your lens at one position, you will find sharp image. You displace your lens, you will again find a sharp image. Then you note down how much distance you moved and let's call it x. Okay? Good. Acha, if I say in general, if this is u and the distance between object and screen is d, then what is this distance? That's d minus u. This is also called the image distance, right? D minus u, because the screen के ऊपर image बन रहा है. Is it all okay? Now, what is the relation between UV and R? So what is B here? That's D minus U. There's going to be plus D minus U. What will be U? U is going to be minus U. Yes? Because it's the other way around. So 1 by V minus 1 by U is equal to 1 by F. So 1 by D minus U plus 1 by U is equal to 1 by F. If I solve this for U, then what will I get? U plus D minus U over U into D minus U from 1 by F. I think some things cancel, and then what will I get? Fd is equal to Ut minus U square, and then U square minus Ud plus Fd is equal to 0. Please look into my calculations. These are very simple steps. Is this all okay? Please check.
Yes, sir.
Cross multiply here, cross multiply करके I have just written in terms of u square. This is a quadratic equation in u. How many roots? Two roots. And how to find the roots? What is the equation?
Minus b
Minus b plus minus under root of
b square plus 4ac by 2.
Can you tell me the final formula? Minus b का ending plus b under root of. बताओ. U square D square D square
minus 4
minus
minus
4
4D
upon 2. Only 2.
2.
These are the two roots that I am getting. Let's try to look into cases now, and then at the end of the case 3 you will understand everything. Case 1 बताओ. Case 1 is this case where d square minus 4ft is actually less than 0. Then does this case exist? Can somebody
No,
tell me that?
because it's a negative and root cannot be.
Yes, root cannot be negative. That will not give me any physically acceptable answer. So what will I get? It's a physically impossible case. Physically impossible. What can be the other thing then? If this is less than 0, the next case can be equal to 0. And what will I get then? Case 2.
D by 2.
D square minus 4ft is equal to 0. Then what will I get?
D by
Then
2.
you will get something like D is equal to 4f. Please check. D is equal to 4f. At this case, what is U?
2F.
That's 2f. Or that's D by 2, no? U is equal to D by 2. Can you check?
Yes, sir.
That's D by 2. Then what will be D? That's also D by 2, na? Because it's D minus U. So V is also D minus U. So if you look into this carefully, only at one position if you place your object, when this is the case, then you will find the image only at one position. So you keep on switching, you will never get at two positions the same sharp image. Only at one position will you get the same sharp image. When you place your screen at a distance of 4f. Okay? Now let's say if you were to place your screen at a distance of greater than 4f. That is the case number 3. What is case 3? D square minus 4ft is greater than 0 now. Then what can you say? Then you can say that D is greater than 4f. Please check if it's correct or not. Huh? So if you place your screen at a distance of greater than 4f, then in how many places will you find the same sharp image? Let's try to do that. So ये root non-zero हो गया? Non-zero हो गया, then how many possible roots?
2.
Two possible roots. एक है d plus d into d minus 4f by 2 और एक दूसरा है d minus 4f divided by 2. These are two possible roots. That means what? It means that at these points if you place your object, you will find the same sharp image. This is not even possible, so we are not talking about it. This is possible, but you will only find one position for which you will find the image, and for any value for which this holds, you will find two positions. Is it? Two positions. These two positions can be termed as U2 and U1, which I wrote initially. Let's call it U2. Let's call it U1. Then can you tell me what is the difference between U2 and U1? I think it was X. It was X, right?
Yes.
Then what is the equation? That is mod of U2 minus mod of U1. Achha, which is the greater one?
U1.
U2
is greater.
U2 is greater.
U1.
U2 here, U1 here, maybe. Okay, check into this later on. But anyways, the equation is mod of U2 minus U1 is equal to X. And if you do the calculation, this is where I like to be called a teacher, where I can give you directly, and you just have to follow the steps and find it yourself. The answer is something like this. F is d square minus x square divided by 4d here. No, it's correct. तो वो पूरा रूट लिख के उसके बाद सॉल्व करना पड़ेगा, स्क्वायर करना, डू ऑल द थिंग्स एंड देन निकालना। क्या आएगा पक्का है। I trust in my students that you will get it. You can check it yourself. So this is a way in which you can actually find the focal length by experiment. You keep on switching the lens, you try to find this x. Once you have found this x, you can find the focal length directly because d is a known quantity. Good. There's also one more relation which I am just going to tell you. I am not even deriving that. That if again, if you want its derivation, you can check in DC quantity. Yeah. I1 is image length of image 1. I2 length of image 2 and O is object length. Then the relation is this is the relation. You can check it if you want in DC quantity. What do I mean by image 1 and image 2? So obviously for different positions of this thing, lenses, just because you are getting the same sharp image does not mean you are getting the same image. But be mindful of that. It's not the same nature actually, but rather sharp image. You will get a sharp image. Should I write the procedure at the end or is it in your minds? ठीक है? लिख देता हूँ। This is the displacement method. Once you are okay with this, you can start with the sheet again. Question number 7. For question 7, let me give you the diagram.